To understand kinematics, you must first understand what vectors and scalars are. Vectors and scalars are both quantities, but the difference is that vectors have a direction while scalars don't. For example, velocity is a vector because it factors in what direction it is going, while speed is a scalar because it is just how fast an object is moving. Furthermore, while looking at linear velocity and acceleration, you must understand that velocity is the change in displacement over the change in time, while acceleration is the change in velocity over the change in time. To solve questions using kinematics, the four equations that you'll use are Vf squared equals Vi squared plus 2AD, Vf equals Vi plus AT, d equals Vit plus half AT squared, and d equals Vt. The variables in these formulas are Vf, which is final velocity, Vi, which is initial velocity, acceleration, which is A, d, which is displacement, and t, which represents time. You also need to remember how in freefall problems, acceleration is just gravity, which is represented as 9.8 meters per second squared, and it can also be written as g. Here we will do an example problem. Our problem will be that a person accelerates from rest to 4 meters a second in 2 seconds. What will their average acceleration be? Because they started at rest, Vi will equal 0, as the initial velocity is 0, and when they end at 4 meters a second, that means the final velocity is going to be 4. And because it takes 2 seconds, then the time will be 2 seconds. With this knowledge, because you have the initial velocity, the final velocity, and time, you can use the equation Vf equals Vi plus At to solve for the acceleration. By plugging the values into this equation, you can get 4 equals 0 plus 2a, as Vf on the left of the equation sign is 4, and Vi is 0, so 4 equals 0 plus 2 times acceleration, as t is equal to 2. By further solving the equation, you would get 2a equals 4, and then dividing both sides by 2, you would get a equals 2, which gives you your average acceleration as 2 meters per second squared. Unlike the previous problem, which was done in a horizontal plane, freefall is done in a vertical plane. The problem will be that a ball is dropped from the top of a 50-meter tall tower. Find its velocity when it reaches the ground. In this situation, because the initial velocity is given to us as 0, as when dropping something, your initial vertical velocity will always be 0. Displacement is given to us as 50 meters, as it is a 50-meter tall tower, and acceleration is 9.8 meters per second squared, because it is free fall, as in free fall, your acceleration will be gravity, which is 9.8 meters per second squared. Therefore, we can use the equation Vf squared equals Vi squared plus 2AD, because we have all of the components to the equation except for one that we need to solve for. By plugging the values into the equation, you'll get Vf squared equals 0 plus 2 times 9.8 times 50, as Vi is going to be 0, so it's going to be 0, plus 2 times acceleration, which is 9.8, and times 50, which is going to be just distance for d. By further solving the equation, you will end up with your final answer as 31.306 meters seconds at the base of the tower, from just multiplying 2 and 9.8 and 50 together, and then getting the square root of them. Now we will move on to adding vectors. Adding vectors is pretty simple. To add vectors, all you need to do is add the tip of one of the vectors to the tail of another of the vectors. Finally, the vector sum will be the line drawn from the tail of one of the vectors to the tip of one of the other vectors, as shown by this dashed line in this picture. Subtracting vectors is also very similar to adding vectors. In this problem, we're going to be using the same two vectors that we used to describe adding vectors. To subtract vectors, you'll need to flip the vector that you'll be subtracting from. As in this problem, we'll be subtracting vector A minus vector B. So you would flip vector B. Again, we'll be adding the tip to the tail to get our resultant vector, which is the answer, as the dashed line. Now we're going to move on to projectile motion. To solve for projectile motion, you need to find the components of the actual velocity using basic trigonometry, like using cosine to find the x component and sine to find the y component. For our problem, we're going to use a ball which is kicked at 17 meters a second at an angle of 40 degrees. The final question is that what is the height of the ball at the top of the arc? As you can see as shown on the image above, on the x side there is v times cosine of theta, which theta is the angle, and on the y side v times sine of theta, which is, obviously, to say that again, is the angle. This leaves us to start solving the problem. This leaves us to solve the problem vertically, as we have all the vertical values needed to use the equation vf squared equals vi squared plus 2ad. Your velocity final will be 0, as the final vertical velocity at the top of an arc will always be 0, and you will have an initial velocity of v times sine of theta, as that is the y component of the initial velocity, and your acceleration will always be negative 9.8 meters per second squared, as that is just gravity in this problem, and that's vertical. Next, we're going to start plugging in the values, and as I said before, Vf is going to be 0, and Vi is going to be the y component of the initial velocity, which is going to be 17 times sine of 40, and as I also said before, acceleration is going to be negative 9.8 meters per second squared. From there, we will square 17 times sine of 40, and that leaves us with 119.408, and then multiply negative 9.8 and 2, which will leave us to minus 19.6d. After that, we are going to subtract 119.408 from both sides to get negative 119.408 on the left side, which is equal to negative 19.6d. And finally, we'll just divide both sides by negative 19.6 to leave d isolated on one side, which will give us our answer of 6.092 meters. As always, thanks for watching, and I hope this will help you.